Hello, very good morning, all. Let's wait for a couple of minutes and we'll start the session. Hello, very good morning. We'll wait for another couple of minutes and then we'll start the demo class today. Yeah, good morning, all. Thanks for showing the interest on this demo class about microservices and architecture today. Let me share the screen and then I'll go for an introduction about myself and the program structure as well as we'll go for the demo classes. Let me share the PPT right now. Hope you guys can able to see my screen, right? If you can able to see the screen, then type yes in the chat box. Yes. So my name is Mohammed Yasir. I have 15 plus year of experience in banking as well as Java domain. So I'm working for bank and I used to providing the solution architect to the bank's projects. So I love to solve the problems for the bank and bank customers to resolve the issue and build the scalable architecture in the banking systems. So this particular vast amount of experience will give you the more insight about how to understand these microservices and how the architect works. Again, you can easily use this knowledge and you can able to crack any interview that I can able to give you a promise about that. And coming back to the today's demo class, today we are going to check out what exactly the software architecture and what kind of architectures are present in the market. What is their own advantages and the flaws about, not flaws, it's kind of cons about the particular architecture, how we can able to overcome all these challenges. That's what we are going to look into that. So before kickstarting the demo class today, I want to give the general information about this demo class, how it works for the next couple of days. As I can share you the PPT, the general information goes like this actually. The first two sessions, today and tomorrow, will be a free to attend. And the next session, third session, will be shared only to the registered participants only. But the recording, this sessions will be being recorded on the fly. So today and tomorrow, the session will be recorded and giving to you. You can free to access the particular videos. The first is day one session, right? The recorder will be uploaded to the YouTube channel that you can able to check it. That will be shared in the WhatsApp community as well. The day two recording will be only for the paid participants only. The day one session will be available in the YouTube channel of the Logic Labs that you can able to check it out. The day two recording will be only paid to the paid participants only. So no batch shifting. Once you enroll the course, there will be no refund. All the session updated will be provided in the WhatsApp community. Okay, so join the WhatsApp community and follow the announcement options. Okay, so whenever the batch shift, I mean, not batch shift, it's kind of bad like cancellations or any add-on cancellations. Okay, any new extra classes are going to happen, that will be communicated in the WhatsApp community. Just follow that community and get that announcement options. Okay, all the sessions will be recorded and notes also will be provided at the end of the day. That will be available in the Graphy LMS. You can connect with this, the provided number and email ID for any other clarification and queries. Okay, so this is the general information I would like to provide you before starting the session. Let's go back to the today's agenda. Let me share the PPT. So today my notes are not working actually, so I'm not able to write down. So tomorrow it will be being fixed actually. So today it will just me. I can use the OneNote for the notes preparation. Let me share my PPT. Give me a second. Hope you guys have gone through the course thing, right? Course agenda, right? So as part of this particular course, what are the topics will be being covered? That will be circulated already. Okay. that you can check it out. So today, as part of our demo session, I'm just sharing the PPT right now. Yeah. So today is the day 1 of the demo session. So what we are going to cover up in this entire course is mastery in the Spring Boot and microservices. As we provided in the course guideline, some basic knowledge about Spring and Java is required. Yeah, I got a ping. Give me a second. Yeah, thank you. Thanks. Okay, the course content will be being already provided by the team that you can check it out. So today, as part of the day 1 demo session, we are going to cover some set of topics about the software architecture that I'm just sharing here. That's about the agenda of the day. Okay, so what is software architecture? What type of architectures are present in the market? So some difference. What is SOA? What is monolithic? How the monolithic is having the advantage, disadvantage, and why microservices we need to study. Okay, what advantage, challenges? Those are the some set of topics we are going to cover up today. Okay, that's about the agenda of the day. So I used to follow some set of things in the session. Usually that starts with the motivation. So definitely we need a motivation to explore any of the skill or any of the task, right? Definitely we need a motivation inside us to drive it. So that way, whenever I go for a session, I used to do this practice to make them motivated. That's why I start with this. So it's like today, believe you can, and you are halfway there, right? Rudolf Roosevelt. That's one of the good motivational quote that we can take it up for today. Okay, then coming back to the things, the next slide. That's about some kind of guideline we can follow throughout this session, this course or demo class or whatever. The first 5 to 7 minutes goes for the recap of the last session because I want that continuity should be recalled so that you can connect with the next session easily. So that's a pre-request. So 5 to 7 minutes, I'll go for a recap of the last session so that you can able to recall if you are not able to recall in the weekdays. So next session, that is current session, will start usually with 8. I mean, it's a timeline, you just change it out, no problem. Okay, usually it start with 9:10 if you want. Okay, fine, 9:10. Okay, so 10 minutes I'll go for this particular recap. So if you have any doubts on the ongoing topic, you can on the fly, you can raise the hand or type the text, or you can put the question in the tab or the chat box. We will discuss then and there and we'll clear out because that is very important, right? Whenever I'm taking a new topic, if you have doubts in that concept, either you can raise the hand or type in the chat box. We'll pick the question. If it is related to the ongoing topic, then we will address it. Maybe some of the questions may be out of the context, right? That we will park it in the end of the session. That will be being cleared out. Though it is not related to the ongoing topic, we will pick it up and we will fix it at the end of the doubt clarification session. That is planned for last 5 to 10 minutes usually based on that course session, right? If the course topics are covered for that time, then we can pick it up. If it's if it is overflowing, then we will pick it in the next session. No problem. Anyway, it will be addressed. Don't worry about it. So feel free to ask the question for the better clarity. That's why we are here, right? We'll take it up all the questionnaires, no problem. Okay, feel free to ask the question as many as if it is basics also, so that we will be in the clear context. Okay, fine. That's about the clarity how we are going into travel. Okay, so let's jump into the topic without wasting the time. First thing. So what is software architecture? Why we need it? That's a basic thing. Something if you are learning, you have to understand why we are studying so that we can clear the context and we can get into it easily. Okay. So what is software architecture? What does it mean? Why I need to study that? Right? It's a fundamental structure of the software system. What is fundamental? For example, that's why I have given a clear diagram here, right side here. So when you are building the house, we are not straight away taking the brick sands course into action, right? We are not building starting. We are planning the first things. We are planning. So where exactly my rooms are looks like, where it will be being located, where the kitchen goes, where the bedroom goes. We are planning in front, right? How the gate community will go. Okay, where my parking will go. So everything we are planning and we are visualizing in the diagram so that it will be easy to maintain and we can easily construct the things just very easily. Okay, if something went wrong, we can able to easily figure out where exactly the flaw is there and we can able to alter it, right? That's what the clear point of it. So that's why we are going for a drawing or something like planning or of the particular house plan. The same way applies for the software also. When you are going to construct any of the e-commerce application or any of the banking application, something like that, any of the startup if you want to do, we are not going to get the requirement directly and then on the fly we are coding, we are not deploying, not like that. We are taking good quality amount of time to understand what exactly my requirement is. That's the functional, right? Functional requirement. Other than that, we have non-functional requirement as well. Like what is non-functional? Something is not related to the business requirement, right? Something not related to the business requirement is called non-functional. So what is that? Business problem we understand. Okay. So for example, if you want to construct any of the e-commerce application, you want to select the product and you have to order it. Simple. That's a business requirement. Okay, that's fine. That is more than that. We have a non-functional requirement as well. For example, today I'm starting with a small team of 2 to 5 developers and I'm constructing the e-commerce application. That's fine. So tomorrow, if the application is going to market and hitting the huge market hit, then of course the users will be being incremented definitely, right? Based on the outcome of the project, we'll get the more clients from the market. That time, your application should have the capability to scale up easily and can able to manage the user request. That load we can manage it. That is the only then your application will serve in the market. Otherwise, it will be ruled out, right? That's why this particular planning is very much important. That is why we can call it as a software architecture. That's why I'm saying that's a fundamental structure of the software system. Okay, it's kind of discipline. What exactly the structure looks like in the system. Okay, example. So what is the tech stack we are going to follow? Okay, so what is the kind of asynchronous communication? How are we going to handle it? How the internal components will talk each other? Okay, so how to handle the failures or exception while communicating to the 2-bit modules or 2 components? How are you going to manage it? So those kind of disciplining things is how are you going to handle it? That's the thing we required as part of the fundamental, right? Once you decided this thing, once you done the small hands-on on that particular thing, then it is open for the developer to build that on top of it. So this particular software architecture is quite very important phase of the project. One project should have to build the scalable standard, okay, or software. That's very, very important. Okay, that's what we must need to study this software architecture. It's a fundamental structure of the software system. That's what. So coming back to the next slide, that's about what are all the software architectures were there and its own characteristics and advantages and uses. That's what we are going to study now. So we have quite a number of architectures are present in the market still. Okay, so we know quite comfortable with monolithic architecture, and we have service-oriented architecture (XOA), event-driven architecture, and finally microservices architecture. Every architecture has their own advantages. Definitely, we can compare exactly to make directly come there. Microservice is good. That is fit for all the use cases. We can't decide like that. Every architecture has their own use cases, the problems. For example, if you go for a good example in the current market, take an example of the Netflix. So Netflix is the major streamline component, right? It's a media streamline partner, right? So something like that. So they went to microservices architecture. Then they were facing the problem. I think Amazon Prime also facing the same problem about streamlining the picture. How the picture will be come into your mobile or any of the devices, definitely it will be streamlined, right? All the media things will be streamlined in the network and coming into your devices based on the ABS, right? So based on your network, the bandwidth, based on that, the particular images will be streamlined into your devices, okay? So now the problem here is they were facing the issue in the streamlining the media components into your devices because of some XYZ problem, very internal. That's why I'm saying XYZ problem. Okay, when they were backtracking the problem because of some particular piece of service is giving a trouble to make the streamline process heavy. So what they decided, they were converting their architecture from microservices to monolithic architecture. So now they are in the market. Prime, right? Amazon Prime is the current in the market. They are still reverted their architecture from the microservices to monolithic. That's why I'm telling it is, we can't decide straight away. This is the best architecture. We can't decide that way. Based on your use case, your own problem, how we can able to go for a workaround. Based on that, we can decide what exactly will suits for the particular use case. The best practice is if you are going to start up any of the project, then very easy to start up is monolithic architecture. That's a quite easy takeaway because you have very limited number of developers. You can have a single source, right? Single source unit that you can able to build it. That is very quick compared to microservices architecture because it has modularized. Maybe I'll come back on that particular concept of microservices later. But just a small point here. If you're going for microservices architecture, it will be modularized. All the components will be broken down into small units. Then it is very hard to maintain at the initial phase of the project. That is very limited number of developers. If you have startup, the good suggestion is like if you have very minimal number of developers in the initial phase of any of the startup project, then you can go for a monolithic architecture. It's a single source code and single unit of service. You can easily maintain and go for a easy development. Okay, so that's why it's all based on your use cases, your own problems, or what you are facing in thing. Based on that, we can decide. That's why it is very critical. You have to put a lot of energy, lot of work around on the phase of architecting the system. Initially, when I was working as a developer during the time, my software architect will be there. He will be just giving the solution. Okay, you can try this combination, it will work. Nowadays, it's not like that. We don't have any solid software architect here. The software architect, we should be available from the phase of software architecting the system to delivering the project. He will be always part of the project delivery nowadays. When I was a developer in the 10 years back, it was not like that. He will just give the solution and he'll go away. As a developer, we struggle each, right? We'll struggle a lot to make the decision into the fitment of the project. It's very hard. When the project is in trouble, he will might not be available. He will be engaged with the other project where he is providing the solution. That's what it was. Now that things are totally changed, he will be part of the project end to end. Whatever the solution he has given, that should be resolved at the time of development phase, and then he will be part of till the project delivery. That's what it works. So now coming back to the topic. Okay, so in the current market trend, we have this set of maybe more than that also, but I want to focus mainly about this four software architecture. It's a very quite base for you people. So monolithic architecture, microservices architecture, and service oriented architecture, and finally event driven architecture. These are the basic things are there that we will take it out. So any clarification, doubts so far, you can just put it in the chat box or raise the hand. We'll clarify it. Okay, let's go on to the monolithic architecture. Okay, that's the first architecture. Okay. So you people are comfortable with what is monolithic architecture, right? So because most of the project currently running on the monolithic, people are there. Maybe they are migrating the existing monolithic architecture to the microservices or other set of architecture. That's okay. So now coming back to monolithic architecture, it's a traditional software development approach, right? So it will be a single source of code where all the developers can go and commit the code, and they will build the package, and they will be building the jar or var, and they will put it into the application app server. Okay, application service. That's what it is, right? Monolithic architecture. It's a single unit of the source code. Okay. So before that, you people understand what is service actually. That is very, very important. Why we need to understand service? What is service? For example, you're going to Google and you're just typing India Pakistan match. Okay, when you're typing IND, Google is providing you some set of suggestions, right? How it is being done? That functionality is called type head function. So whenever you're typing IND in the particular Google search box, then it is giving you the auto suggestions. So whatever the combination with IND, all the suggestion text is being displayed in that particular search box, right? That functionality is called type head. Okay. So now when you are typing your interested topic in the Google search box, when you're typing, it is giving two works to you. One is the Google is giving you the auto suggestions based on the typed keyword in the search box. And also it does what is the exact thing you're typing in the search box. That relevant topics or links will be provided to you as part of the result, right? Two things it is does. How it is being done? That's what it is done by services. You got my point, right? Why we need to understand service? Because service is a base important if you're going forward. Okay, that's why I'm putting the word service. So ultimately, so Google is providing you the two services, one for completing the text. what exactly you're typing in the search box. IND, India, Pakistan. Okay, something like that. Okay, IND. That time, what are the combination of what is a good result sets related to IND that suggested text will be being popped up. That functionality I said it's a type hit function. Okay, so it does for you first service. Second service, maybe the suggestion text may not be relevant to your search originally. Then you are typing India weather, something like that. India weather. Okay, so maybe something related to India economics. Okay, India India weather. Yeah. What are the combination if you think through? What not? Yeah. Now the Google is second service it is accomplishing. That is nothing but when you hit the search box, search button, then it is giving you the exact search results to you. So that's another service. So two services it is done by the Google in this case. So now coming back to that exact result set. So what is service? Service is nothing but you people know, right? MVC, model, view, and DAO, data section, data layer, right? So all the three you people know that's called MVC layer. So now what is service is simple term. Service, what is service is? It is a combination of your business layer and your data access layer exposed as a endpoint. That is called service. Very simple term. Maybe I'll use the notepad so that you people can connect what I'm trying to say. Okay, coming back to what is service, right? What is service? What is service? Well, service is nothing but it's a combination of service layer. Maybe it's maybe source. Maybe 1 minute. Let me maximize the text so that people can easily see. Yeah. What is service? Service is nothing but the combination of service layer plus data access layer. Okay. And exposed as a service endpoint. Okay. Maybe it's a REST or SOAP, something like that. Okay. Anything can be. Okay. So this is called service. When I am typing the Google search box, that's what it does. Google is doing the same kind of services exposing already. Whenever you're typing the keyword in the search box, it is going to invoke the type head service, which is nothing but giving a suggestion or auto completion text to you. That's a point number one. Point number two, the second service, which is coming and fetching the exact type text in the search box, that suggestion it is giving you. So two services are exposed from the Google perspective. One for a suggestion, auto completion, another one for the exact search text. Simple, right? That's what it does. So it means service. This is what I'm trying to say. What is service? Service is a simple thing, combination of service layer concept or business layer concept plus data access layer. That is nothing but the DB, right? And these two things is combination and exposed as a service endpoint. That's called service. Okay, very simple thing, but it's very important to understand at this point of time. Only then you can go in deeper in the other concepts. Okay, let me come back to the maybe I'll use this particular thing. As a user, you will be typing the things. Okay, it will be going to the load balancer, and load balancer will be communicating to the API gateway, right? API gateway, and then it will go for a server, right? That's what it works, right? So as a monolithic application, your entire unit, single unit, I said, right? So what is monolithic architecture? It's a simple single source code base where you will be building the application as a simple var or jar and deploying into the your app server. Maybe we'll treat it as an app server. Okay? Very simple app server where you will be deploying the var file. Okay, this is what it does in the monolithic world. This is what happening. So tomorrow I'll use that writing part. Maybe it's very hard now. Okay. So this is what happening in the monolithic architecture. Okay. Any doubt so far? Are you okay? Any clarification you require? Please let me know. So maybe I said right, this word I have put it already in the monolithic architecture. If you're doing the startup, you can go for it. This is the word I have kept it, right? So, but the problem comes when your application is growing more and more. It's very difficult to manage such a huge code base. That's a point number. Very, very important point number. Because you have two developers, source code is little less, then you can manage it very easily, right? So I'm putting the word point here also so that you can easily connect. Okay, so it's very difficult to work on the huge code base. Why it is difficult? Because when you are using the single source code, okay, you have your classes, maybe a monster classes may born. What is monster classes? You have a method. If your method is should be a policy, you have to follow the solid principle, right? That's a base. Maybe solid principle, maybe I'll come later. But solid principle is a keyword you might be heard in the market. So it's a kind of design principle. Okay, so how you have to construct the things in your application. That's what it does. Okay, so now when you're building any of the functionality in your source code, you can write the controller class or service class or DAO layer class. You will be writing it. So when you're starting writing in the same application code, maybe for the different cases, different projects, right? Slowly your code base will be keep on increasing because more developers are being built, being deployed into your project. That time your code base will go higher and higher, right? That time it's very hard to manage it. Agree? Correct? So now second problem comes. So development becomes slow due to the high build time. Because if you are I'm a new developer coming into your project, okay, I need to take a time, right, to understand what exactly this particular code base is does for the project. I need a time as a new developer. I coming into your team, I need a time to understand how this architecture is working internally, how it is being called from one component to other component. So here ultimately development became slow due to the high build time, right? So development becomes down, correct? And underscore, it also become slow, or it's become slow. Let me put it, okay? So whenever a new guy is coming into picture, definitely the problem comes. So here one more problem, very, very important problem. Whenever a small issue comes in your any class, I think any class I put it, okay? Any class, maybe it is in a presentation layer, maybe I'll put it skipping this business layer or DAO layer, any place. If any small issue happen, what will happen? Your entire application goes down. Agree? Because it failed to start your application itself. It's completely down. Your application will not be exposed outside. So you got the point, right? So this next point, because I already said difficult to onboard a new engineer into the team. Correct? He has to come into picture. He had to understand it. That's very hard. It takes time. It's difficult to onboard a new engineer into your project very immediately. If your requirement is very timeline is very tight, it's very hard to onboard the new engineer. He need a time. He need a KT. He need to understand completely. Then, of course, as I said, development becomes slow. Correct? Next point. What happened? Debugging. The application debugging will be slow, definitely, right? Because he taking time to understand the things. When he are developing, definitely his debugging things also will go down, right? Application debugging will be taking time. That's another problem. And I said difficult to onboard the new engineer into a team. That's another problem. There's one more problem is coming, which is nothing but you have to stick with one technology only, right? So it is not a technology very tightly stick with the one technology. Okay. So you can't switch the other technology very easily. So what maybe I'll put the word simply like it's a kind of single technology. No text. We will put the word no tech stack. No tech stack flexibility. We'll put the word correct. Okay. So it means that if you choose Java as your base code base to building the monolithic architecture, you build the things. Okay. Now, one point of time, maybe Python is coming into picture nowadays, right? So Python is doing better functionality compared to Java in particular one case, then you can't accommodate that in your application. The Python thing you can't integrate it. Integrate meaning not component to component. I'm telling inside your code base you can't accommodate the Python code. So that's what I'm telling. No tech stack flexibility here. You got my use case, right? For example, Python is doing better for the file transmission, something XYZ functionality. Okay. Now Java also does that, but maybe comparatively the time taken for Python code is lesser than the Java code base. You can't take it up. You can't go to the Python code base and put it into your development stack. It's not possible. It does not support. Okay, so that you have to choose the technology very initial phase. You have to stick with it. You have to compromise. You have to trade off. You can't achieve everything, right? As per the cap theorem, you have to adjust something. That's what it does. Everything has their own compromisation, right? So here also you have to compromise on the one particular stack. Okay, that's why I'm telling no tech stack flexibility. Okay, of course, technology there's regression or maybe testing or regression will be time will be taken time because it's huge code base, right? Ultimately, you have to test if you are doing any small functionality change in particular use case, then of course you have to, as part of regression, you have to completely test all your application, right? Definitely, right? That is very mandatory. That's why it is taking time because code base is huge. It's a single source code base. Everything is clubbed as a single unit, right? So definitely the testing also will take time. So you understand the things. Any doubt so far? You are clear about all the 7 main points about microservice, I mean, monolithic architecture. Any doubts you can ping in the chat box. Any doubts? Are you people comfortable? The phase, what I'm going and the concepts, are you clear? Any doubts? You can free to ping, clarify it then and there. Yeah. Okay, fine. Let's go back to the other thing. I'll sharing the PPT once again. I'll go for the PPT share. 1 minute. I'll go back. Okay. So coming back to the topic here, PPT. So as I said, all the components, that is nothing but the user interface, business logic, data access, all are tightly coupled and deployed together as a single unit, right? That is called VAR or jar, something. Okay. In the monolithic architecture. So example, it's already given. Most of the applications are running right now in the market also monolithic architecture. They are slowly migrating into XYZ architecture. Okay. So now what is that advantage that we have seen already? The entire application is built as a single unit, simplicity, easy for development in the initial phase, performance, deployment. But why it is performance here? It's a method calls, right? When you are building all the things as a single unit of source code, it's nothing but the method call. Method call is quite very fast compared to, right? Compared to network calls, one component to other component, that is comparatively your method calls are very fast because you are calling from A method to B method. It's very fast compared to one service to other service, right? That's the advantage of monolithic architecture. Okay, it's very good in the performance. Deployment also very easy because you will be taking the var and putting into your application server. That's it, done. Your application is completed. So easy for the development in the initial phase. Performance is quite okay because it's a method call. Ultimately, it's a single unit. So your method calls are ultimately within method call only. It's very fast. And deployment perspective also, you can easily deploy the var file into your application server. That's it. You can restart the server. Everything will be done. That's about the process. What is cons? Flexibility and agility. As I told you, agility, it's very hard, right? And coming back to the second point, scalability and technology stack limitation and fault isolation. As I said, that use case, technology stack limitation, you have to stick with the only one tech stack only. All right, you can't switch the tech stack very immediately. That's not possible at all at the phase of like a development phase. Once you are completed already, right? You can't take it up. And coming back to scalability, as I told you, it's a deployment as a single unit in the application server. For example, very simple case. Assume you build the system in the monolithic architecture way and deployed into the app server. Okay. Now you are promoting to the market. So your product is super hit. Our product is attracted by multiple users. Now multiple users are downloading your app and then started using it. So one point of time, your application will not withhold the incoming request because every resources has their own potential or capacity to handle the load. So whenever you are going higher on top of the CPU utilization or memory of the server, definitely you have to procure the next server, right? So the problem with this particular point here is, in as part of the monolithic architecture, single source code deployment into your app server, you can't do the scaling. You people know, right? What is scaling? Scaling is nothing but based on the load, incoming load to your application, you can increase the resources, server resources parallelly or horizontally. That is what scaling. Whenever the request is coming into down, that is less request into the resources, you can minimize the server resources. That's called scaling. Maybe I'll go back to the notes and then I'll draw some couple of drawing so that you can connect what I'm trying to say. So coming back to the scaling concept, maybe let's quickly done this. Okay, scaling is nothing but, as I said, as a user, I'm hitting the request to your application. Okay, so this is my apps application. So now what happened? This will be routed to the servers, right? Backend servers. Maybe it's a load balancer, and then it has the app servers. Okay, where my var is deployed. Okay, so now the request is more and more. My app server will not withhold the request. Okay, ultimately I can go for a next server. This maybe I'll name it as app server 1. Okay, so next thing, what I'm going to do, I'm going to increase the one more server that is called server 2 with the same deployment source code. Okay, so now servers 2 also coming. So now this load balancer will be maybe multiple algorithms are there. Maybe round robin is quite familiar on the load balancing concept. Maybe that using that, it is also routing the request into app server 1 and app server 2. Okay, now assume the Amazon big days sale, something like that is coming, right? That time they'll go for a more offers. That time definitely the users are more interested on the particular offer, and then they will hit the application more and more, right? So assume that the day is big days sale where your two applications is not able to withheld. Okay, again you have to recruit or procure, right? Another server, that is server 3 and var, right? This is what scaling actually. Okay, what the problem here with the concept is, with the monolithic, right? So once the load is less, right, you have to remove the application server. It's not no more required actually. Here the main problem is you are deploying the war file into your application. Okay. For example, very simple use case. Maybe I'll put this use case problem. What is the problem now? Use case problem. Okay. Here, what is the problem is actually maybe this particular war has all the functionality. Agree? All functionality. What is all functionality here? Maybe I'll be maximize this. Okay. What is all functionality? As a monolithic, everything like your user authentication, right? Your authentication or user profile or any functionality like e-cart application like order service. I'm just typing order service, product service, or your payment service. All the things will be putting as a single unit source code, right? So every functionality will be built as a var and deployed into app server. Okay, so all app servers have the same var. It means all the functionality is being deployed across all the app servers, right? So now now you use case problem will come. Okay, so now you tell me how many users go to the user profile and changing the profile picture or updating the address compared to ordering the product. You got my point, right? So now the use case problem is how many users are going to user profile service and updating the profile picture or updating the address or updating the mobile number, how frequent it is compared to ordering the product. It is very, very, very less. Agree? Maybe 2% of the total load, right? Correct? Agree? Total load of maybe order service. Agree? Agree? But still you are deploying that particular functionality again and again into all the app servers. So when the more load is coming for the order service, right? Order only is the main priority for these guys, right? After authentication, definitely you'll go for a order only on the big day sale. So even though you know that thing, but unknowingly you're deploying all the user profile service also, although application 2 and 3. Because of that, what happens? You are not using the service and deploying unnecessarily, occupying the resources, app server resources. That is the, because you can't do that because it is a single var. That single var does have all the functionality as a single unit. You can't take it out, this user profile service from the var because it is a monolithic. It should be come as a complete package only. You can't avoid that. So though the user load is increasing with the order service, still we have to take the service along with you only, no other option. That is why the problem comes into picture. Okay, so you can't avoid, you can't avoid the unused or less used. Maybe I'll put the word less used so that less used functionality, okay, in deployment. Okay, you can't avoid the list functionality used in deployment. You can't avoid it. You have to go for it. N number of server if you deploy also, you have to take this functionality along with you. Okay, without the load consideration. Okay, the another problem is coming into picture. That is nothing but you can, in the monolithic world, all right? The war monolithic. Okay, in the monolithic, the war deployment. Oh, sorry. Deployment comes with horizontal deployment or scaling only. What is horizontal? What is vertical? I'll tell you. Maybe sorry, I put the word wrongly. It's a vertical. Okay, vertical scaling. What is vertical? I'll tell you. What is horizontal? I'll tell you. Okay. So what is vertical? Vertical is nothing but you have to scale the system vertically. What is vertically? Increase the memory of the server. So increase the CPU of the server. Okay. The processing, right? Request per second, the processing you have to increase. Okay. For example, what is that vertically? I'll tell you. Maybe if you have memory of maybe 100 GB, something like that, you have to increment with 200 GB. Okay. So if you have a CPU, maybe 2.5 hertz, 4 gigahertz, something, right? You have to increase it to 5.2. So that's the way you have to increase it. It's the same server, you are increasing the capacity from 100 GB to 200 GB to handle the processing of the request. Same way, you are increasing the CPU utilization from 2.4 gigahertz to 5.2 gigahertz. Okay, this use case usually fit for the DB servers. Any of the DB server like MySQL or Oracle or DB2. Okay, those are the servers will go for a vertical scaling usually. Okay, that's what you will be increasing the memory capacity of the server little more. Okay, that's what it does. Okay, that's called vertical scaling. Okay. Okay. If you're going for the horizontal scaling, okay, what happens? That's the main advantage for thing is if whatever the load you feel, okay, that you can deploy it. For example, you are interested on product service, you understand that on the big day, say definitely order will be huge. Then I want to focus about the order service only. Okay, so order service on the fly, you can deploy it to server resources. Okay, server. You can avoid unused or less used. Maybe I'll put the word less used services into a server deployment. That's advantage, right? You are utilizing the server capacity very knowledgeably, right? Now you forecasted that this is what going to happen. You can avoid it. You can deploy. I mean, you can deploy the user case, no problem. I'm saying user profile service. Sorry, service. You can deploy less number of server we can deploy. You understand, right? That's okay. Maybe one or two instance is fine to handle all the user profile update service. That's no problem. But you understand that more order service will come into picture. Then you can go for a horizontal deployment. What is horizontal deployment? Very simple. It is nothing but you are creating the same instance again and again. For example, you have one server have capacity of maybe same 100 GB guy, same guy, 100 GB of 100 GB memory plus 2.4 of gigahertz. Okay. So this guy is there already. If you want to increment one more guy, you will just replica of it. You will not do incrementing the memory from 100 to 200. Instead of that, the same capacity server, you will be replica of it. And then deploy the var. Okay, deploy the jar, maybe jar or var, something based on that thing. Okay, the same jar and var you will put it. Okay, so you got the advantage, right? You don't need to deploy the unused service again and again and occupying the more spaces of the server. It's not required at all, no more. Okay, it's called horizontal scaling. Okay, understand the concept? Vertical scaling is this is what, horizontal scaling, this is what. Okay, now coming back to the problem statement. Now we are deploying all the unused things again and again into all the app servers. The monolithic architecture, we can't avoid that. That's one thing. Second thing, we always go for the vertical scaling for the monolithic architecture. Okay, cool. That's what it does. Okay. Now coming back to the PPT, any doubts so far? Are you clear about the concepts what we said? Any doubts? You can free to ask, no problem. If even it is basics also fine. Happy to help you. Fine. Let me go back to the PPT again. Yeah. So you people understand now what is the pros, what is cons, right, about the monolithic architecture, right? Clear? Okay. Coming back to the next concept, that is called service oriented architecture. Okay. So here it is like it's like thinking about how we can able to modularize it. So now you have a monolithic architecture. Every code basis has a single unit of work now. Now you're thinking about this problem. Okay, this has some problems. Let's go for some resolution, right? So for that, it got born the service-oriented architecture. Okay. So what is service-oriented architecture is you are designing the things. Okay, in the particular single unit of code of monolithic, I can what are all the piece of code I can modularize it. For example, as I said you, right? So user authentication service, user service, profile service, product service, right? Order service, payment service, notification service, all the things you are viewing as a modular now. Okay. So you are breaking down your single unit of code base work into small piece of modulars now. Okay. What are things modulars that you are thinking right now? As I said you, the user service, profile service and all, and how we can able to reusable it, and then loosely coupled. Here you now you are thinking about modularity, so you are going away from the loosely coupled structure. Okay, that's called service oriented architecture. Okay. So as I told you, applications are composed of services that communicate with each other over a network. Okay. So now you are breaking down your single code base into multiple modular. You have done the loose coupling now, and then you can go for a how this communication will happen via network. So for example, the order services will not done everything, right? You can't done. It needs the products inventory service, whether the particular product is really available in the database or not. For example, simple use case, I'm logging into Amazon application. I'm trying to order the iPhone 14. Okay. So now that particular product should be available in the database, right? It should be available. Only then I can able to order, right? So now as part of the order service, it is also have a dependency of product inventory service where the product is really available in the DB or not, right? If it is available as part of the particular order service, it should deduct the order quantity from the DB also, right? Only then the other user can able to make it clear. Very peculiar case maybe the particular order is having only one count in the database, right? If we both are trying to access or order the particular same product, then there will be a problem. If you are if you are not detecting the available count in the DB, it is giving a problem at the time of ordering, right? So it should depend. So your order service should have a dependency of the product inventory, payment, notification, everything has reliable, right? That's what modularity is coming into picture. Okay. So as I coming back to the SOA, so applications are composed of service, modular service, right? For example, user service, notification service, product service. How it is being intercommunicated? It is via network. Maybe I have a picture. Maybe I'll show you. Then you can easily connect it. Give me a second. I'll go back to here. So in the service-oriented architecture, as you can refer the point, the slide, this particular piece I'm telling. This is a monolithic. So it's a single unit, right? Now here, all the modules are identified and deployed as a modular way, right? So here, maybe assume it is a user service, product service, order service, payment service. Okay, all are identified and deployed as a modular components into the server. Okay, how it is being the communication is being made as part of this particular network bus, EBS, right? Enterprise Service Bus. The communication will be taken place. For example, assume it is the order service, it is a product service. Okay. Now, if you want anything to reduce the count of the product, then of course, the order service will communicate to the product service via the enterprise service bus. Okay. So this is how the network call will happen. Even though it is quite costly to set up initially, is as part of SOA, you done the purpose initially. You are breaking down, identify the modularity, and then you deployed as a component into the server as an independent modular service, and then you're communicating via the network service bus called enterprise bus service bus. That's how the communication is taken place in the service oriented architecture, right? So now coming back to the slide, service oriented architecture, what exactly it does? Each service is a self-contained unit of functionality. Okay, each service, whatever is service I'm telling, user service, profile service, also self-contained unit of functionality. Maybe some of the e-commerce applications are also running on the SOE architecture right now in the market. So coming back to pros, flexibility, scalability. So whatever the required service, if you feel the load will be higher on the particular day, that particular component alone, you can able to scale up. That's the pros of the SOE. And interoperability and maintenance will be easy. Okay. And coming back to the cons, as I told you, the communication is over network. So definitely network calls will be costly. You have to set up the initial infrastructure cost to establish the SOE architecture. That's a costly operation. And then you have to work on the message brokers. So message broker, you people understand, I think. Okay, so whenever you are when you are going for the asynchronous mode of communication, you have to use the brokers or queues. So ultimately, broker will be sit on top of the particular queue, queue manager, and he'll take that accessibility, and then it will allow you to put the message. On the other end, the consumer will be consuming the message and work on that particular task. So message brokers or service registries. Okay, all the things is you have to establish. That's a quite costly operation. Is cost involved. Okay. That's about service oriented architecture. Now coming back to the third one, which is microservices architecture. Okay, so that's one we are going to work on is further more modules and sessions. Okay, so now what is microservices? Why we need it? Okay, only then we can go in little deeper into it. Okay, so now you understand the problems about monolithic architecture. Now understand about the service oriented architecture. That pain points we understand now. So now it's a time to look into the microservices architecture, why it is being used, what is the purpose of it, right? That's what we are going to do it. So now we are modularize it. That modularity I'm going to expose as a service in the monolithic architecture. As I told you, what is service yearly? I've given you the example also, right? In the Google example, whenever you're typing the keyword in the search box, it is giving you the required auto completion text and relevant text information, right? All the things it is giving you. That's called services. Now we come next level. What is microservices, right? So microservice is nothing but it's an independent services. So whatever things the use case you want to do, that we are exposing as a services. For example, user profile services, user authentication services, product services, okay, order services, like that. Independent services we are exposing now. As I told you, very good example, right? Google, when you're typing, it is calling the one more API call to get the auto suggestions for the search keyword, right? The same way, we are going to deploy each and every modular code as a services into the application server. That's why I'm telling it is a independent services. You got the point, right? Independent services. Okay. So now coming back to this microservices architecture decomposes an application into smaller, loosely coupled services. The service is the keyword. Very important keyword is services. Okay. I told you what is services. Now I'm just linking the dots. Okay. So You got it right. So why we are going for a services? You can easily deploy the things as into small services and then make the work done for us. Each service is responsible for a specific business capabilities, functionalities, and can be developed, deployed, scaled independently. Very simple, right? Now you understand you are assigning the role to each microservices and make the work done. Here, user services do this activity. Okay, expose as an endpoint. Whenever I need, I'll call your endpoint. You make the things done. Just giving the instruction like that. Okay. So that's why you can easily deploy it and maintain it easily. So example I have given here already: login, order, inventory, notifications. Okay, these are the modularities I have identified and then exposed as a independent endpoints or services to outside world. So whenever I'm logging in, I have already exposed endpoint, right? Service already. What is service also I have said, right? What is service? Service is nothing but the combination of business layer and DAO layer and exposed as endpoint. That is called services. Now, in that perspective, I'm exposing the login services now. Okay. So now whenever the user is logging into my e-commerce application, I am going to call this login services. That will be connecting to the my DB or business validation, whether username, password, valid or not, all such combination business validation. Then it will connect to DB, it will authenticate and it will give you the home page. Okay, this kind of things are identified and exposed as a services. Okay, so as I told you the use case, right? So whenever you feel the less used modularities, that you can avoid it at the time of scaling, right? So for example, on the big day sale, coming back to the big day scale, the user profile service will be less used, as I told you, right? That you can deploy it into one or two services, servers, and order services, inventory services that you can deploy into multiple servers in the horizontal scaling pattern. Okay, so that way you can able to accomplishing the scaling independently and easy to deploy and maintain it. You got the point, right? Now you understand what is the service. These are the breakdowns we have done. This many services we have exposed. Based on the use case, what I told you on the big Amazon big day scale kind of scenario, you know that compared to the user profile services, most of the requests will be hitting the order microservices only, right? Order service only. So I will be scaling more and more order microservices into horizontal scaling pattern to managing the load. Okay, that is possible in the microservices architecture style. That's why I'm telling scaled independently, right? You got the point, right? Okay. Coming back to the third point, communication between the services is typically through the lightweight protocol because we used to call in the HTTP pattern, right? In the microservices world, the communication between two microservices is via HTTP or messaging systems. That's the way we will be communication protocol will be. So this architecture promotes flexibility, scalability, and ability to adapt the different technology for the different services. Okay, as I told you, the scalability you people already understand now. Whichever services getting the more load that you can able to horizontally scale it, right? So whenever the request load is less, it will be minimized to the one or two services. Whenever the request is more, it will be horizontally scale and 10 to 15 based on the load will be auto scale it. So that is what scaling is, right? So microservices supports the horizontal scaling. Our monolithic architecture will support the vertical scale only. That is no possibility of horizontal scaling because of the limitations. So now coming back to the different topic, that is nothing but the adapting the different technology for the different services. What is that? You remember in the monolithic architecture, I said that the technology stack limitation. Once you chosen the technology, you can't change it. That's the limitation of the monolithic architecture. But in comes to microservices architecture, right? You are free to adapt the different technology for the different services. For example, think about the scenario. Okay, for example, your notification service is quite fast in the Python world. Okay, so you understand, right? Whenever you're ordering the any of the product, once the payment is done, your notification will be coming into your email and mobile, right? Say that Amazon, okay, so and so order is placed on so and so date. That's it. Delivery track. I mean, you will track also. That's fine. Okay. So this particular piece is telling notification service. Okay. So notification service contains the email notification, SMS notifications. Okay. Assume. Now, this particular functionality is quite fast in the Python world. Python language, if you build the notification system, it is quite fast to deliver the notification. Assume, think like that. Okay. Now, your entire application, whatever the application you build, login, order, inventory, all are in the Java world. All are chosen as a Java as a tech stack, and you build the system. Now, one point of time, you feel that okay, Java notification service is not quite fast. Somewhere it's stuck up. It is the notification are delivered little late to the customers. Maybe it have the bad experience, right? So in that point of time, you think that yeah, Python is doing better than Java. So why not we try that? Now, microservices architecture giving the flexibility to you to adapt the different technology, that in this case Python, right? To build the notification service. You got my point, right? So now think that no login, order, inventory on top of the Java technology stack. You build the system. Now notification alone, Python you can do it. You can do it. That is called adapting the different technology for the different services. So now my order services can talk to notification service, which is built on the Python language. There is no restriction as part of the microservices architecture. That's what we are telling, that adapting the different technology as per the use case, as per your difficulty, that you can able to build the system. Right now, there are multiple e-commerce applications really does this in the market. So for example, Netflix, it's a quite using this way of different adapting technologies. Okay. So what is the takeaway from this slide? Microservice perspective. First point, independent services. Agree? Independent service. What is independent? You can able to break down the modularity, login model, order model, product model, inventory model, everything you are breaking down as a services. It means that independent services. Second point, I told you tech stack flexibility. You can adapt any technology language to build any of the services. There is no limitation. Okay, that's why I'm telling tech stack flexibility. Second point. Third point, we already discussed, individually scale our services. Assume if you feel order services get the more load, you can do the horizontal scaling for order service alone. There is no restriction. If you feel your user profile service will be less load, you can do based on the load, you can scale it. Whether it is 2 instance, 4 instance, based on the load, individually scale for services. So now you are breaking down all the single source into small independent services now, right? So definitely deployment will be less. Agree? Deployment will be less time takes, build time also less time takes. Agree? Because you're narrowed down, right? User service alone, user profile service alone, order service alone. It's very be specific to the one use case. So definitely you are have a small piece of code only. So easy to deploy, easy to build the things also. Now I'm connecting the dot. Onboarding a new engineer will be easy. Agree? If I am a new guy going to be part of your development team, definitely I have to work on some XYZ model. That is nothing but, for example, you assume order service microservices. I am going to enhance it. So definitely the code base will be little less na, compared to monolithic. Agree? I don't have user profile services, order services. I don't have. I have very limited scope now. So what is that? Maybe product service. Okay. I have to work on only products. I have to check out the product service code alone and I have to work in. So now I don't need to check all entire application source code. I have to understand. It's not required. I have to very be specific about product microservice alone now, right? So focus is be less compared to monolithic. So onboarding a new engineer will be easy. Agree? I am new to project also. I can able to check out the product service code. I can able to understand because its scope is very less compared to monolithic, right? So easy to debug, understand, easy to develop, understand. Onboarding a new engineer will be easy, right? Testing will be, regression will be easy because of course the code is less. Definitely testing also easy, regression also easy, debugging also easy. Agree? Very important point. If there is an issue with some service, right, it will not impact the entire application. Agree? Because in the monolithic world, any piece of information or code is breaking, then the entire application will be go for a toss. Some example, build some deployment has something went wrong, your application will be gone. But in the monolithic application, right, it will not like that. For example, if you have a notification, deployment gone wrong, your notification functionality will not work. Agree? The rest of the model will be deployed as independent services. It will not harm the application. Only notification will not work. Whenever you are placing an order, yes, you can do. After placing order, will you get the notification? Yes, you will not do because your application is down. The particular notification service is down. So you will not get the notification. But later, once it is brought up, you will get the notification. Okay. So now the scope and the changes you can see, right? Multiple advantages I can see. Agree, right? So independent services, tech stack flexibility, individual scale as a services, deployment will be easy. You can easily build time will be less, right? Completely because less source code, build is easy. Deployment will be easy. Onboarding engineer is easy. Testing regression with less source code, definitely easy. Debugging, yes, less source code is easy. Okay. Now the main advantage is if something issue in the some services will not impact the entire application. That's a major advantage. Agree, right? Hope you guys understand. Any doubts so far in this? Please let me know. Are you able to connect what I'm trying to say? Any doubts? You can ping me. We can connect. Any doubts so far? You are welcome to type in this chat box. I'm happy to help you to address the queries. Hope you are aligned with me. Thank you. Okay, fine. I'm just showing the diagram about the microservices, how it is being pictured. Okay, so assume it is a UI component where the user will be being interacted initially. Then based on the services, the request will be routed to the respective microservice. For example, it is a login service, it's a profile user service, and it is order service or microservice. Okay, inventory services or payment service like that. We identify as a individual component as a service, and then we deploy it as a independent component. Okay, now the based on the request endpoint, we will be routing the request from the load balancer. Okay, so this is what the picture looks like in the microservices world. Any doubts? You are free to type in the chat box. Any doubts so far? You may feel, okay, you are telling all the advantages about microservices based application. That's fine. It has some downsides also. But luckily we have the remedies. But I'm telling there is downsides also about the microservices based architecture. What is that? Whenever you are breaking a module as a small piece of components, definitely you have to interact. So inter-service communication would be time consuming because services need to talk to the over network. Agree, right? When you want to talk to the product microservices, right? The order services should be talk to product microservices. It should communicate to find the quantity of the product. If it is find, then you have to reduce the quantity in the DB. This is the time it has the intercommunication over the network, right? So it takes time. So whenever you're going for a network call, definitely it takes time to accomplish the task. So here the time will be taken. So latency is coming into picture. When you compare monolithic with this microservices architecture, latency will be more. I got a ping 1 minute. Can you enable my audio? Yes, definitely. Give us a second. Okay, allow me. Yes, you can talk now. Yeah, sure.
Thank you, sir. So if we understand this microservices,
yeah,
each service or each, in other words, each activity is differentiated as a service, right? For example, if
correct.
you take a company, and you were giving example as order management. In order management, let's say one server is one service, means placing an order is one service,
Okay,
and notification is a separate service, and then
correct,
probably getting the responses, etc., is a separate services, right? Fulfillment is a separate services.
correct, correct,
Server.
correct.
Uh, that's what you call everything as a microservice. I think I confused between the monolithic SOA and microservices. So if you monolithic is the advanced, then why people go for SOA and microservices?
So monolithic has the advantages. I agree because the intercommunication is like a functional call, Java functional call. It's quite fast. When the problem comes actually in the monolithic world, it has some limitation, right? So what is the limitation? Lot of limitation, right? Because the code base is big, you can't put that into a horizontal scaling. That's not possible. Very
Okay,
difficult to manage such a huge base.
gotcha.
Whenever the code base is bigger and bigger, when you are onboarding any new engineer into your team, he has to face the difficulty, right? Understand entire code base, and he has to work on the
Let,
functionality what you assigned.
yeah, let
Okay.
me ask a different way. I'm sorry, I
Yeah,
meant
yeah,
to
yeah.
say. Uh, so monolithic obviously has some drawbacks.
Correct, correct.
SOA also some drawbacks, but
Yes.
microservice is the um, more benefits. Is that right? Is it my understanding is right?
Yeah, more advantage, but it has some problem also. Downside
Okay.
also it is there, but we have a remedy
Okay.
to support, remedy to support. For example, I told you, right? When you are calling one microservice to other microservices, definitely you have to travel the network. Latency will be higher compared to monolithic. I agree. So network hub also will be there, right? Sometime network is gone down, then this
Hmm.
particular package will be lost in the network itself, right?
So
Those are the, yeah.
I'm sorry, are you defining this in the terms of the on-premise environments or cloud environment?
No, whatever way,
Whatever the environment it is, doesn't
whatever
matter.
different way. Yes.
Okay. Okay.
It has to travel, right? One microservices will not accomplish all your work done. As I told you, order microservice has the dependency with the product services, payment services, notification services. All the dependencies are there, right? It is not an individual guy who can done all the work for you. That's not possible. It has some dependency also, right? I told you the product count should be updated after the placement, the order, right? Only then
Okay.
you will be get the consistent count of the device. So that's why it has some dependency also in particular use case, right?
Okay.
That's what I'm. So it has the, it needs to communicate. Inter-service communication is required. It is time consuming. Network hop will be there. Latency will be there. We can't take out that downside, but we have a better plan to remediate it. How we are going to work on that item, how to fast track it, that we can do it. Furthermore classes I'll cover up.
Okay.
So now you understand what exactly so far I thought, right? So service oriented architecture, monolithic, microservices, why we are adapting, what is our own flaws, everything you can able to take it out from this, or you have any other questionnaires?
No, sir. Thank you.
Okay. Thank you, Shiva. Thanks for, I'll unmute you. Give me a second. Yeah, fine. So I told you the downside of the microservices has the intercommunication between the two microservices. It definitely will go to travel the network. Of course, the latency will be higher compared to monolithic. Also, network hop will be there. Sometimes we lose the request package itself. Okay, fine. So what is the next drawback or complexity or downside of the microservice? Nothing but complex to manage the multiple microservices. Today I have 4 to 5 microservices that I can able to manage. But tomorrow, if it is born more and more microservices, right? For example, use case like I need a something like new functionality component one. For example, some uh, download file microservices. Okay, so other one is like a PDF editor microservice, like that. So many microservices are keep on increasing in my project. So whenever it is go more and more microservices, it's hard to manage. If I have 4 to 5, definitely I can able to manage. But multiple microservices keep on growing. It's very complex to manage in perspective of building, deploying, and test. Right? That is the next downside of the microservices. Okay, so tracking, okay, becomes a challenge. So for example, I told you the use case, right? When the order is placed, you have to check the product quantities available or not. Now, in this case, order service is making a call to product service to check the quantity and coming back to product service, order service, and then it is going for a payment service to placing the order. Okay, now there are multiple network calls. Also, you have to track the request, right? So tracking is little challenge. Okay, for example, very use case, one particular order got failed. Okay, now you have to track it. How do you track it? You have to go and check the order services whether the request is going to product inventory service or not. That you have to track it. Okay, so now you have to go to the product service whether the particular request really reached or not. Okay, if it is reached, whether it is updated the count or not, whether it is updated, it is returned back from the product microservice to order microservice properly or not, whether order microservices received that response or not. So again, you have to go back where the payment is made or not. So you have to track each and every microservices one by one. It takes time. So that's why I'm telling tracking becomes a little challenge. You got my point, right? In the in the monolithic world, you can easily track the request because it's a method call, just a logger printing statement. You can easily, by seeing the logger, you can able to get the things. But in the microservices world, you have to track the different microservices. What are the dependent microservices you have to track? Whether request received or not, processed or not, returned back or not, everything you have to track it. So that's why I'm telling that tracking becomes a little challenge. Okay, these are the downsides are there, but we have a other resolution are there that we are going to cover up in the further more sessions. Okay, so everything we have a solution for the microservices. Okay, any doubts so far? Are you fine with the microservices? We are more go more and more. But I can't cover up everything in the single session. More and more interesting topic and real-time scenarios are there. Okay, now coming back to the PPT on 1 minute. So now, why microservices? That's one thing we can ask. Why microservices? Okay, why we are choosing the microservices? We have multiple architecture is there. Then why we are choosing the microservices architecture? That is already addressed. But anyway, I'm just want to recap it. So it is using HTTP communications. It's a very lightweight protocol. Okay, to easily travel in the networks. So REST is the one thing. Second one, small, well-chosen deployable units. I told you, right? Broken down already. User services, product services, order service. Everything is chosen as a modular and broken down still as a deployment, individual deployment unit. Very easy to maintain. And it is also cloud enabled. If you want to go for a one cloud provider to another provider, yes, it supports. Even cloud provider is also supporting major number of functionality to supporting the microservices nowadays. Okay, it's easily cloud enabled. That's why I'm telling cloud enabled. And the scaling also we have talked about. It's easily to scale horizontally based on the estimated request load. The less request load about the user profile service, you remember that you can horizontally scale, but limited number of services you can deploy in the server. Order services expected more load. You can deploy more horizontal server resources, 10 to 15 based on the load. That you can, based on the load, you can estimate the how many resources, server resources I'm going to deploy. That you can estimate and you can able to deploy it. Whenever the request load is less, it will be auto scaled down to 2 to 3 servers. Request is more servers are deployed. That's called scaling, horizontal scaling. Okay. Based on the load, the resource will be incremented or decremented based on the load. Okay. That's called scaling. And then flexibility. What is flexibility? Without affecting the entire application, you can go for the other microservice. I told you your notification the service is down for some time due to so on reason. Your entire application will not impact. Still it work as such. That's the flexibility. And resilience and fault isolation. As it is a small in size, independent component is easy to deploy and maintain it. So we already taken these points already. Just putting it up. Even that challenges also we have discussed, right? What is that? Complexity of distributed system. You have to communicate multiple microservices. Data management complexity. So you have to maintain the integrity, right? That's very, very important. So integrity is you have to maintain very, very much carefully. Otherwise, the fault read will be happen. So data management complexity. You have to maintain the data properly, even though you have multiple microservices. Service dependencies and communication. So this communication is very critical, right? It has to travel to the network. Definitely expected latency will be there and the network hop will be there. So initial setup and infra cost is more. That's why I'm not preferring when you are going for a initial phase of the project. If you go for a startup, you can go for a monolithic because it needs fast development, easy to deploy as a small piece of source code. When you are initial phase of the project, when you are going to major things, you can adapt the microservices. So it needs the initial setup and infra cost because each and everything is a service server you have to deploy. And you have to secure your application. That's very, very important, right? You can't allow the XYZ guy to access your microservices and make the work done for you. You have to protect your application layer. Then security come into picture. How are you going to secure your application? That's another challenge. Anyway, we have a resolution on hand that we are going to cover up further more sessions. So I'm just summarizing all the points. So complexity of the distributed systems, okay, and data management complexity, and then communication, infra cost. To setting up the entire application setup, you need to invest money, and you have to protect the application from the external world. Okay, those are the challenges of microservices. Okay, now coming back to the next one, what is Spring Boot and why it is needed? So now we understand the different architecture style. What is the advantage of it? Each has their own advantage. Okay, so we saw monolithic architecture, we have saw SOA architecture, and finally we saw the microservices architecture. Okay, so now we understand what is architecture, what are the type of architecture, everything we understand now. Okay, now it's time to go a little deeper. How to build the microservices architecture code base. Okay, so for that we are having a lot of technologies are outside to build the microservices architecture style of code. As part of our course, we chosen the Spring Boot as a technology stack. That is nothing but the framework to choose to build the microservices for us. That's why Spring Boot coming into picture now. So Spring Boot is a popular framework in the Java Echo world that addresses several key needs of challenges in the modern application development. It's a one Spring Boot is nothing but the it's also under the Java Echo world only. It's we can say it as just a wrapper on top of the Spring framework. Very easy. On top of the Spring, you know the Spring Echo world, right? So I think I have a next diagram here actually. That's a Spring Echo world. Okay. In the Spring Echo world, we have a data access integration, web, AOP aspect, business core container, everything we have. All this will be being supported by the Spring Boot also. It's a kind of wrapper on top of the Spring Echo world. That is nothing but the Spring Boot. Okay, coming back to the previous slide. Spring Boot is a popular framework in the Java Echo world that addresses several key benefits of challenges in the modern application development. It's very easy to set up and configuration is very less. Because when I was doing the development, right, during the time I used to set up the workspace. Whenever I have assigned a task, I have to do the workspace setup first, right, in my local. That's very, very painful and important step of the project. To setting up the workspace, right, it takes a lot of time to do the setup initially because it has n number of configurations I have to manage properly. Only then my application will start up. Otherwise, it will not start up. Hope you guys also facing now in your trend. Okay, so it has in the Spring application and all, it has a lot of configuration to make the things work done to bring up the application. So it is very painful for the developer to complete that initial setup. Maybe 1 week also it takes to set up the workspace. But these pain points of the developer will be overcome by the Spring Boot application. It has very less number of configuration to make the things done up and running. You will see it in the tomorrow. I'll show you how to bring it up, how easy it is compared to Spring. So that's another thing. So Rabbit development, because you have to mainly focus as a developer. You have to mainly focus about what is the business problem given by the business. For example, if you want to do fund transfer from A to B person, your use case is transfer the money from A to B. That's it, right? You have to focus only about this business problem only. You don't need to bother about how you have to bring up the application, how to configure it, okay, how you have to manage this setups and all. You don't need to bother about. Everything will be owned by the Spring Boot application itself. As a developer, you have to mainly focus about the business problem only. You have to code that business problem alone. Rest of the configuration, I'm telling the keyword less configuration. It doesn't mean no configuration. It has configuration, but it is very less compared to the Spring applications. Less configuration. Okay, that's why I'm highlighting the word less configuration. If you do those so, you can easily bring up the application very easily. You don't need to break your head to set up the initial setup of the project. It will be easily done by the Spring Boot itself. How it is done, that is the separate story that we will cover up tomorrow. The auto configuration and dependency injection, that I will discuss later, but it is too heavy now if I talk about that. Okay, so production ready features. What is production ready features? That is also we'll cover up tomorrow. It is nothing but I'm just giving a little higher points. Production ready features is nothing but if you want to go to the live to the production environment, you have the capacity to monitor and maintain the application. Agree? It is like driving the car. If you know that, if you know driving the car, it doesn't mean you are just pressing the accelerator alone. It's not like that. Going fast doesn't mean you know the drive, you know how to drive the car. Whenever someone is coming middle in the road, you have the control to keep the brake and make the no impact. That's also a very much important skill, right? To driving the car. So that is the same use case here. If you build the system, make the things done for the use case, it's not completely ready. Once you have the capacity or intelligence to monitor how your application is behaving based on the load, the user load coming into your application, how it is being, how it is tracked, how the metrics are exposed outside, how you are monitoring, where what is the health check, whether his application is up or not. So everything you have to have the provision to monitor these features and all. That's why the Spring Boot providing such a provision to your application to keep monitoring all these features. This is nothing but the production ready features. Okay. Very simple use case example. For example, the user is hitting the order microservices. Okay. It takes so on so time. Okay. This particular use case, what are all the resources are used? How many seconds it taken to process out the response? Okay, what is the request? What is the CPU utilization for the particular processing the request? So everything will be keep monitored by these production ready features that we are going to cover up and aspect of actuators. Okay, so that's a simple example I'm telling. The production ready feature is nothing but not only deploying that into the application to keep monitoring the health of the application. That is called production ready feature. That is Spring Boot itself providing such features to our application. As I told you, integrating with Spring Echo World is very easy because it's just a wrapper on top of the Spring Echo World. This also we discuss cloud native capabilities. What's it? You can able to deploy your entire Spring Boot application into any of the cloud provider, whether it is Amazon, AWS, AWS, Azure, okay, Google Cloud, anything it supports. That's the beauty of the Spring Boot. I'm just summarizing all the points quickly. It's quite familiar and it's under the Java Echo world. Very less configuration, developer life easy, and it is rapid development. Why it is rapid development? Because as I told you, the less configuration and you have to mainly focus about the business problem solution only. Rest of the configuration or less configuration will be taken owned by the Spring Boot itself. Example, embedded server. In the Spring application, you have to put the var file into embedded server, not embedded server, external server, and make the configuration done. And then you have to bring up the Tomcat server or anything, Tomcat or Genti or anything. You have to bring up. It need a configuration. If the configuration is not working, less or somewhere missing, it will not bring up. That kind of pain points will be removed by the Spring Boot itself because it has come with the Spring embedded Tomcat server or Genti server or something. It has. So that's why as a developer life is very easy because it has less configuration. The deployment will be taken care by Spring Boot itself. You have to mainly focus about the business problem only. I'll come back the auto configuration dependency injection little later because it's too heavy now. So production ready feature, I explain you about the monitoring and health metrics about the application. You need a tool to track the end to end. That should be ready, which is provided by the Spring Boot. This all the Spring Boot will be being supported by the Spring Echo World. Whatever the Spring is exposing and providing the services, all will be being utilized by the Spring Boot itself. So it has the advantage of Spring Echo World plus Spring Boot feature itself. So it has two advantages. So final point, cloud native capabilities. It means that it supports all the cloud providers. Okay. And coming back to the last slide, which is nothing but the difference between Spring and Spring Boot. So as I told you, the pain points in the Spring project, you have to configure by your own as a developer. It has the XML based configuration, right? You, for example, if you want to create any of the controller, what are the dependencies are there, right? You have to put the bean declaration with the required dependency, the XML. So here in the Spring Boot, there is no XML based configuration. We can completely avoid that file, that integrate anything star.xml. You have to configure this bean declaration, right? At the time, only then your Spring container can able to understand and create the bean and put it into the Spring container. But the Spring Boot, it's no way. We don't need to go for any of the XML declaration. We don't need to do that. Will be handled separately by the auto configuration that I'll talk to in the maybe further more sessions. Okay. So here the takeaway is no XML based configuration in the Spring Boot. I told you the abstraction on top of the Spring Echo World. So it means that it whatever the Spring is providing right now in the Echo World, it providing to you every functionality will be consumed by Spring Boot application also. It's just just a kind of inheritance kind of it. So it's a developer friendly. Why it is developer friendly? I already discussed, right? It's very less configuration. It's coming with the embedded servers to make the deployment very easy. And you have to mainly focus about the your development only, business problem only. You can avoid unwanted problems like setting up the workspace, bringing up the Tomcat, bringing up the application. Everything will be owned by the Spring Boot itself. So you no need to bother about the configuration related pain points. That's the beauty of the Spring Boot. Why Spring Boot? Spring Boot is one of the framework to make the microservices application, to build the microservices application. That's why we choose on the Spring. It is one of the framework to build the system. Okay. So now you understand why we are studying Spring Boot, right? So what are the architectures are there? What is the advantage about it? Everything we have. Right. So now it's a time to QA. Any doubt so far in the furthermore slides or context out of the context, please let me know. You can free to type the chat or you can raise the hand to make the questionnaires. I'll be sharing this PPT to you people. Yeah, I got one more hand. Give me a second. Yeah. If someone raise the hand, yeah, Harita. Yeah. Yes, Harita, you can go for it. Yeah.
Yeah, hi.
Yes, Harita. Yeah.
Yeah, what is the course structure?
I think you people might be have visited the link, right? If you are not sure, I'll walk through that. What are the topics we are going to cover up in this particular?
Okay, is it
Entity.
completely practical or theoretical, or do we have any
Okay.
practical?
Okay. So today is the day one. Okay. So I need some theoretical knowledge to you people. That's why I'm not opening the code now. So
Okay.
usually how it works, Harita, it will be like a 30-70. So 30% will be a theory because something you need theoretically before hands-on. That's why I'm going through this all stuff. But usually the course works like 30% theoretical, 70 will be hands-on. More and more on hands-on only I'm preferring. That's what the furthermore session was like that.
Okay.
Because I need theoretical, definitely. Only then you will understand when I'm coding, right? That's why I'm going for the slides and all. What is the base class, right? It's a kind of base setup I'm doing. So once the base is ready, then we'll go for a hands-on. Then onwards, it's completely hands-on only.
Okay. Are you going to provide any server, like cloud server for us?
No. Cloud server, I'm going to demonstrate. Okay, so okay, I'll build the things like this. Okay, what I'm going to do now. So now you understand what is architecture. Now we slowly will start picking the Spring Boot. Okay, so what is Spring Boot? Now what is how to start the development with the Spring Boot framework? How we are because Spring Boot itself coming with the embedded Tomcat. Okay, locally that I'm going to demonstrate. Okay, so that then I'm going to pick the one e-commerce application that I'm going to build with you. Okay, so everything is internal embedded Tomcat only, but we are not going to deploy into AWS or something cloud provider and show you. But it's out of context and it's out of course itself. But the course is mainly focused about your theoretical and hands-on only about Spring Boot. It's completely around the Spring Boot only, not the cloud providers. It's not a cloud course. I'm going to demonstrate you how you can deploy the things in Docker. That I'm going to construct. If you go through the course agenda completely, you can have the Docker also. Once your e-commerce application is ready, using that you can build the Docker image that you can able to demonstrate. That I can show you. That is a part of the course.
Okay.
By using the Docker image, you can just deploy and you can run the container and you can able to do it. Yes, that you can do. But AWS is not into picture for your kind information. But I'm going to build the Docker image for you. How to what is Docker? From there, how to publish the Docker image, I'll cover up. That it's that's a course of the.
So Spring Boot is a framework, right, sir? Completely is a
Yes,
kind of
Shiva.
a
Yes,
framework. Okay.
yes, yes.
So can we develop this framework for the existing, what is say, existing company that already using softwares, or we have to start from the scratch?
No, usually whenever you are going to work for any of the Spring Boot application, which is run already live, okay, you will understand what with that our knowledge, whatever hands-on, what we are doing in this session or course. With that, you can able to get what these people are doing in that code, and you can start developing by your own. That's the base context I'm setting up. Shiva.
Okay, when you say developing code, I'm sorry, I just want to visualize it. Do you mind just showing the framework screen or something really quick if you
No.
have?
Okay, I'll put it like this, Shiva. What we are going to do as part of the course, we are going to see what is Spring Boot, how to build the system by using the Spring Boot. Okay, Spring Boot providing the lot of functionality, like Spring, how it is providing lot of functionality like AOP, other aspects and all, right? The same way, Spring Boot also providing some set of features. Okay, with Spring and Spring Boot, we are going to build the system, e-commerce system. We are going to build it. Once it is built, you understand how it works, right, internally, and you can also deploy into the Docker and make the things done. That's what we are going to do. You will end
So
of the
you are
course.
saying will build e-commerce system means we're going to develop
Yep,
the whole e-commerce
yep.
system means
Yes, yes.
how the order management works,
Exactly correct. So we are going
pages,
to
everything.
build the e-commerce system with the microservices with Spring Boot as a technology stack. Okay. And then we are going to deploy into the Docker. That's what we are going to do till the end of the course. So end of the course, you understand how to build the microservices project. That's what we are going to do. With that knowledge, if you placed into XYZ company, If the project is still with your microservices, you can able to go and work on the fly. That's a context. Any doubts, Shiva? Are you clarified? Haritha, are you clarified with the queries what I have asked?
Yes.
Okay, Haritha. Thank you. So I'm going back to the final PPT. Maybe we are overrunning. Maybe I'll come back here. That's a final point. So I'm just repeating the same point. So first two session will be free to attend. The third session onwards, it will be shared with the registered participants only. Day one session, today's session will be being recorded already. Okay, will be published into the Logic Labs Technologies YouTube channel that you can go and revisit and recollect the point. If you have any doubts, tomorrow session you can come and clarify the doubts. No problem. I'm free to help you anytime. No problem. I'm happy to help you guys. Okay. So again, coming back to the day two recording session will be only to the paid participants only. So please join the WhatsApp community and follow the announcement options. If you have any doubts, clarification about the course content or course related item, then you please call this particular two numbers and drop a mail to support at Logic Tag. Okay, this is the one thing I want to repeat again. Okay, you just join this WhatsApp community and follow this announcement option. Very critical thing. Okay. Any doubts technically?
One small
Course?
thing.
Yes, Sarita, please. Yeah.
The service registry you have mentioned, right, in the course
Yes.
structure.
Yes.
What service registry you're going to
It's a
use?
Eureka we are going to explore. Eureka service
Okay.
registry, we are going to use it. Yes, it's once you build the thing, I promise you, you can able to build the system by your own. If you are following my class
Okay. Are
hands-on
you
honestly,
going to cover any design patterns in microservices?
design pattern on the fly, because whenever I am constructing the code, right, definitely I have to introduce you what is a design pattern, what design pattern we are going to use it. For example, build a design pattern for creating the objects and factory design pattern that we are going to use it. But it is not separate topic. Whenever I'm building the code, that time I'll introduce you what is what, and then I'll accommodate it so that you will be getting the multiple blend of taste. You will get it.
Okay.
Any
What
other
circuit
guys?
breaker? Any?
Yep. Yes, we have circuit breaker also. Okay, we have a rate limiter also. How to control the request flow into your microservices, how to
Okay.
avoid it.
What service circuit breaker are used?
Resilience 4G, where are you going to use it? Okay. So
Okay.
yeah. Anything, any other doubt, guys? Any doubts, free to raise your hand. You can shoot the question. Yeah. So if you are revisiting this video, if any doubts coming tomorrow demo session, we will cover up. Okay. Come up with the more questionnaires so that we'll connect, we'll clarify the doubts then and there. I'm happy to help you and I'll welcome more questions. Only then we mutually can understand the system better. Okay. Any more doubts? I'm happy to help you guys. Okay. We are overrunning by 3 minutes. So tomorrow maybe I have a writing pad. I used to write in the pad and I'll share it to you. Today I have some problem. I'm not able to go for it. That's what I was using Notepad. OneNote. Tomorrow it will be sorted out. Don't worry. And yeah, any doubts you can connect tomorrow. Yeah, fine. That's it for this today's demo class. Thanks for interest and attending this wonderful demo session. Thanks so much, guys. Yeah. Bye bye. Happy learning.